Alright, let's see if this works. I'm going to try one and then I will continue going if it happens to work. But I'm not sure it's going to, so we shall see. Okay, so you have to write an equation in standard form of the parabola passing through the points. Now we've done it with a vertex and a point, but this time you're not given the vertex. So what you're going to end up having is a system of 3 equations with 3 unknowns. So if you remember the standard form, it looks like this. We're just going to plug in y and x, and we're going to have a, b, and c left over. So if I put in y here, -1, and then I put in 1 for these two x's, I'll get a plus b plus c. If I put in -5 for y, and then 2 for x, I'll have 4a plus 2b plus c. And then if I put in -7 for y, and 3 for x, I'll have 9a plus 3b plus c. All I did was replace the x's and y's with those x's and y's. How do I move this thing? I don't know how to get this out of the way. Can I drag it somewhere? Oh, there we go. Okay. So now I have a system of 3 equations with 3 unknowns. I have to make a variable go away. I'm going to use these 2 equations and just multiply through by -1 so that the c's will go away. So if I multiply this top equation by -1, maybe I'll try a different color. I get 1 equals -a minus b minus c. So then if I add this equation with this equation, 1 minus 5 is -4. A plus 4a is 3a. B plus 2b is plus b. And then the c's cancel out. And then I'll add this red equation to the bottom equation to make those c's go away. So I'll get -6 equals 8a plus 2b, and the c's are gone. So now I just have a system of equations with 2 unknowns like we had when we did systems. If I multiply this top equation by -2, I'll make the b's go away. So that would give me -8 equals, positive 8 equals -6a minus 2b. And I'll just rewrite this equation over here so you can see it. 8a plus 2b. Add these together. 2 equals 2a. A equals 1. Well, if a equals 1, then I can just plug it in anywhere, any of these 4. I'll go right here. -4 equals 3 times 1 plus b, so b equals -7. So now I know a and b. I can come up to this first equation. If a is, so I'm going to write -1 equals, a is 1, b is -7 plus c. -1 equals -6 plus c. Add 6 to both sides, and c equals 5. So the equation, then, is y equals, a is 1, so 1x squared plus, b is -7, so I should have written minus 7x, and then c is plus 5. Okay, I'll do one more of those. Again, I'm going to plug in for x and y into the standard form of the equation, y equals ax squared plus bx plus c. So here's the equation. I'm going to put in -4 for y, 1 for x. -3 for y, 2 for x. -4 for y, 3 for x. I'm going to multiply the top equation by -1 again. We'll do the c's. Add the red in this one. So 1, 3a plus b, c's go away, and then I'll add the red and the bottom. 0 equals 8a plus 2b, c's go away. Multiply the top by -2. Add them together. B's cancel out. So a is -1. If I put in -1 for a here, I get -8. Add it to both sides. 8 equals 2b. B equals 4. Come back up here. If a is -1 and b is 4, that's 3. So I have -4 equals 3 plus c. So c is -7. So then the equation is y equals -x squared plus 4x minus 7. There's a lot of videos on this on YouTube. If this didn't make sense, you can go watch it. But I also want to show you how to do it on the calculator. So, the table shows the number n of tickets to a school play sold t days after the tickets went on sale. Find a quadratic model. So I could do exactly what I did up here, but there's also a way to do it on the calculator. And there is a page in your packet that shows how to do it, but I'm going to do it right on here. So let's make sure this is working first.